Hey everybody, welcome back to my channel, Numbers with Nora. This is just a math help channel helping you with all your math homework at all types of math levels and all types of math needs. For this particular video, we're going to be working on geometry and continuing with chapter 4. And this section is for 4.4, proving triangle congruence by using side angle side and hypotenuse leg. All right. So this video, I'm just going to be doing a whole bunch of practice problems from out of the book, Larson Geometry. I have the link in the description and also the link for the answers and solution for this particular book, so you guys can follow along. If you have any other homework questions that are similar to these or that you need help with in this section or anything with triangle congruence, put it in the comments. I will show you step-by-step how to answer it and help you out with any questions there, okay? So let's get to it. Again, if I'm moving too fast, go ahead and pause the video and sit there and take notes or whatever, because I want to try to get through as many homework problems as many problems in this book as possible right now. Okay, so let's start with number 1. So number 1, it says copy and complete the angle between two sides of a triangle, or the angle between two sides of a triangle is called the included angle, okay? And we call it the included angle because that's the angle that's in between those two sides when we use the side angle side postulates. All right. Let's go ahead and look at number 2. So for number 2, this says explain the difference between proving triangles congruent using the side angle side and SSS congruence postulates. All right. This one I'll just say verbally. So SAS, basically, we're using two congruent sides that are corresponding and looking for that included angle, okay? So with SAS, we're dealing with the included angle. With side, we're not dealing with any angles of the triangle. We're just looking at all the congruent and corresponding sides of the triangles, okay? That's the main difference. All right, from 3 through 8, use the diagram to name the included angle between the given pair of sides. For this one, I'm just going to do 3, 5, and 7, and you guys can try 4, 6, and 8 on your own. So for 3, we have XY and YW. So here's XY, here's YW. Our included angle is between those. So our angle is going to be XYW. Okay. So now let's do 5. For 5, we have ZW, and then we have YW. Our included angle is between those. So that's going to be ZWY. All right. And then for number 7, we have XY and YZ. All right. So the whole angle in between those is going to be all of our angle Y or XYZ. Right. So those ones weren't too bad. Now let's look at 9 through 14. Decide whether enough information is given to prove that the triangles are congruent using the SAS congruence postulates. Okay. So let's look at number 9. I have triangle ABD and then triangle CDB. Okay. I see that AD and BC are congruent. That's fine. I can also say that BD and DB are congruent by the reflexive property. We sat there and went through that in my last video. All right. But I do notice that these angles are not included angles. They're not in between my two congruent sides. So I would say no, I cannot safely say that these two triangles are congruent by SAS. Okay. Now let's look at number 10. So it says triangle LMN and triangle NQP. Just a second. In the call. There you go. Sorry about that. And triangle NQP. So we do sit there and see our corresponding sides, L and M corresponding with N and Q. The annotations tell us that, and M and N corresponding with Q and P. Our annotations tell us that. These are both 90-degree angles. 90-degree angles are congruent. So I can totally say, yes, these two are congruent by side angle side. Okay, let's look at number 11. For this one, we have triangle YXZ YXZ and triangle WXZ. All right. I noticed that we can sit there and count ZX as kind of like a perpendicular to WY because it creates a 90-degree angle, which is great. So that means this is going to be a 90-degree angle as well. I also know that X and Z and X are congruent because of the reflexive property. But what's throwing me off is this WX and ZY are congruent. XY and WX are not congruent. That's not given. So I can't conclude anything. I cannot use side, angle, side. Okay. So this one's no. Okay. Because that other side is not next to it and corresponding with that. Right. So let's look at 12. We have QRV and then we have TSU. They give us the corresponding sides. If I sit there and look right here, I don't think I'm going to be able to conclude much because again, my angle is outside. It's not an included angle. It's not in between my two corresponding sides. So I would say for 12, it's a no. We can't use side angle side for that one. 13, if we sit there and look at this, again, I could say F and H and F are congruent because of the reflexive property. Then I get a nice little side angle side going on. So 13 is going to be yes. I can use side angle side postulates. 14, I have K, L, M, and then I have M and K. They are telling us these two are parallel. Remember a parallel line, I can sit there and count KM as a transversal that cuts through my parallel lines. Since those cut through my parallel lines, that's going to create some angles that we may be able to use. I can sit there and say that these two angles right here are alternative interior angles. Okay. Or actually, no, I could say that these two, because those don't touch my parallel lines. Apologies. I could sit there and say that these two are my interior angles because it has to touch my parallel lines, right? There we go. Looks a lot better. And then I can also sit there and say that these are reflexive. Okay. They're reflexive, so that means that K, M, and M and K are congruent. So I would say side. Again, my angles, they're not in between my sides. They're not included angles. So I would say 14, no, I cannot use side angle side. No, no, no. Great. Very nice. Let's move on and continue. Here's for 15. 15, this is multiple choice. This is more like a SAT problem. Again, I do a lot of SAT math help as well. And these are the kind of problems where you just want to sit there and try to eliminate the answers and really annotate and see what they're trying to ask. So these are really good problems to work on as well. But for 15, it says, which of the following sets of information does not allow you to conclude that triangle ABC congruent to triangle DEF? Again, annotate. We are finding information that does not say these are congruent. So we want it to be false, okay? We're looking for the false answer. I always like to sit there and draw a little sketch so we see what we're doing. All right, and so they have triangle A, and then B, and then C, and then we have triangle D, E, come on, E, and then F. All right, so let's go ahead and start plugging and checking these in. Let's start with A. They said AB corresponding to is congruent to DE. Okay, let's note that down. Then they also have BC is congruent to EF. Okay, let's write that down. And then they also have angle B congruent to angle E. We have this right here. That looks pretty right to me. It looks like we can use side angle side for that one. But remember, we're looking for ones that do not check off, okay? We're looking for ones where it is not the solution. So let's look at how B is now. Oops. Let me just get rid of these, sorry. No. All right, so let's look at B. For B, it's going to sit there and say that AB is congruent to DF. Okay, that's fine. Then it says that AC congruent to DE. AC congruent to DE. Okay. And then it sits there and says that angle C congruent to angle E. Right off the bat, you're going to know that's not right because we do not have an included angle. Remember, included angle is between my two congruent sides of my triangles. This is outside of them. So it's going to be a hard no for this one. But it is going to be our answer because they are looking for the one that does not allow them to be similar or congruent. So the answer would be B, right? If you would like to go on and plug in the rest of these in the little diagram I drew on your own, that's fine, but I'm going to go ahead and continue to 16. So in exercise 16 through 18, use the given information to name two triangles that are congruent. Explain your reasoning. ABCD is a square with four congruent sides and four congruent angles. All right. Let's go ahead and annotate that down just so we have it noted and we can see it visually. Square does have all equal sides and all equal angles. Awesome. So now they want to sit there and say what triangles we can conclude are congruent, and we have to say why. So I can sit there and see from our annotations that triangle BCD congruent to triangle BAD. And that's going to be by side, angle, side. And I'll sit there and highlight and show you in just a second, just in case you didn't see that. Side, angle, side. Okay. So if we see right here, I have side, angle, side. Okay. Corresponding side, angle, side. I have included angle, which is good. Great. I could sit there and include because I proved that postulates that these two triangles are in fact congruent. Okay. Let's go on to 17. RSTUV is a regular pentagon. Remember, regular polygons are polygons that have all equal sides and all equal angles, okay? So that gives us a hint right there. So let's annotate that. This pentagon is going to have all equal sides and all equal angles. And the pentagon, I believe, is 5 sides. So make sure you're not counting any extra sides or any extra angles. Okay. All right. So now that we have that, I kind of see what's going on. Try to sit there and pause the video and write it out yourself if you can see it. If not, I'll sit there and do the highlights and show you where I see that two triangles can be congruent. I'm going to say triangle STU. And also triangle RVU. Oops, sorry, that V is a little messy. We get the point. RVU, and this is by side, angle, side again. I'm going to sit there and highlight. All right. So I sit there and see my corresponding sides. Okay. My corresponding sides, yes. And then I have my included angle, and these are congruent because we said it's a regular polygon. So we know all our sides, all our angles are congruent, so we're gooch by saying that triangle STU is congruent to triangle RVU. Okay. Let's do the last one. Let's do 18. So this one is saying that MK perpendicular to MN. Remember, perpendicular means that when they touch, they are going to create a 90-degree angle. And then also KL perpendicular to NL. So again, when they touch, they create a 90-degree angle. So if we sit there and look at these as two triangles, they already marked it as they have two sides. But remember, the side across from my 90-degree angle, that's going to be my hypotenuse, right? Let me mark that up. So the side across from my 90-degree angle is my hypotenuse. And hey, we have some reflexive property going on right here, right? So we could say K and N and K are congruent because our reflexive property, which means both of our hypotenuses are congruent. And I have two legs that are corresponding and congruent for my two triangles. So that means that I can sit there and safely say that triangle KMN congruent to triangle KLN. And this is by our, remember, it's not a postulate, but a theorem, our HL theorem. Okay. Awesome possum. All right, let's rock and roll. Let's do a little bit more. I think we can do a little bit more. Let's see, where am I at in Loim? Yeah. So for 19, overlapping triangles. So redraw triangle ACF and triangle EGB so they are side by side with corresponding parts in the same position. Explain how you know that triangle ACF congruent to triangle EGB, right? So for sake of time, I'm just going to draw the second triangle out really quick. And this is C, this is A, and this is F. Okay. And there's a midpoint right here where it has like these two are congruent. Okay. Another midpoint right here that goes like that, I believe, yes. And then instead of drawing a whole nother triangle, bear with me, I'm just going to erase and block this one out. Okay. All right. And then we should have our two triangles. All right, that's good enough. So all right, let's go ahead and see how these two, if we can sit there and explain how these are two congruent triangles. So I can sit there and say that BE and FA are congruent. I can say that because we have both these two tick marks. If I add both these segments together and both these segments together, I'm going to get the same thing, right? This is called segment addition, okay? So I can sit there and say that BE, because they both have the same markings, okay? So they're both congruent. So if I add both those segments on both of them, they're going to be congruent. So BE congruent to FA, and we can go by segment addition. By segment addition segment. I'm just going to go like this. And if you want to learn more about segment addition or don't forgot about it, look at my geometry videos. I'm just going to put a plus sign right there, segment addition. So, okay, that's good. And then also, I know that, again, GE and CA are also congruent, and that's also by segment addition. GE congruent to CA. Again, that's by segment addition. All right. And then I also know that across from here, my BE is my hypotenuse and also my FA is my hypotenuse. So I have two hypotenuses that are congruent, and then I have two legs that are corresponding legs that are congruent. So I can say by our HL theorem that these two triangles are congruent. Okay. My HL theorem. Awesome. These aren't too bad of problems, right? They're pretty easy. All right, so let's do 20 through 22. Decide whether enough information is given to prove that the triangles are congruent. If there's enough information, state the congruent postulates or theorem you would use. All right, so let's look at 20. On this one, right off the bat, I know I'm not going to be able to use the postulates. My angles are not included angles. These are not right triangles, so I can't sit there and use the HL theorem. So I'm just going to say there's not enough information. Not enough info. Okay, so no. 21. Z is the midpoint of PY and Q and XQ. Sorry, I had a brain fart. So Z is our midpoint. So by definition of a midpoint, that means from here to here, from X to Z and Z to Q, that's congruent. Because a midpoint breaks a segment into two congruent halves, okay? And then Y to Z and Z to P, that's also congruent. Okay. Then I also know these are vertical angles. This angle XZY and PZQ, those are vertical angles. So it looks like I have some side angle side action going on right here. So I can sit there and say there's enough information to state that these are congruent. So I would say congruent by side angle side. Okay. Now for 22, let's take a look at these. Again, if we thought like if we looked at these like they were broken apart, we could sit there and use angle addition. So L and N by segment addition like we did before, segment addition. Since these all have the same markings, if I added these and added those together, they're going to be corresponding, right? So I can say L and N and L and S are congruent. That's by segment addition. And I can also say M and N and R and L are congruent. Those are marked together. Yes. R and N. And congruent to M and N. Notice that across, these are my hypotenuses. My hypotenuses are congruent, and I have a leg that, two corresponding legs that are congruent. So I can say this is by HL. Theorem, hypotenuse leg theorem. These two triangles are congruent. Oh my gosh. You guys know what I'm trying to say, theorem. I think my hand gets tired after writing on this computer all day. Theorem. There we go. It's better. All right. This is going to be my last one, or last two. I'll do these last two. So 23. Suppose both pairs of corresponding legs of a right triangle of two right triangles are congruent. I always like to draw out when people are giving me something in words. I like to see it visually. Okay. Just helps you make sure that you're understanding and getting it right. So let's kind of sketch up. They said two corresponding legs. So corresponding legs, let's say this leg and this leg and this leg and this leg are congruent. Okay, these are my legs of my right triangles. Okay. Are the triangles congruent? Explain. If we just look at these, I have two sides that are corresponding and congruent. So I can do side, and that angle is included because it's in between my two corresponding sides. So for sure, I would say that these could be two corresponding triangles by the side angle side theorem. That's another thing in math. If they're telling you something verbally and you can't really understand it, don't be afraid to draw it out, because like sometimes when you visually see it, you'll be like, oh, okay. All right, so this last one, let's do an error analysis. I love a good error analysis. Describe and correct the error in finding the value of X. All right, so let's see what they're doing right now. So we could say that these are two corresponding angles or triangles. So Y, Z, and ZY, those are congruent because of reflexive property. They already marked down that these are congruent, okay? And then these are both congruent as well because they're both the same value, right? So since I can sit there and prove that this triangle, these two triangles are congruent by side angle side, congruent triangles have all equal sides and all equal angles, okay? All equal corresponding sides and all equal corresponding angles. All right, so let's sit there and see how they set this up. I believe they messed up here. Remember how I said you have to use the corresponding sides? So this side right here, YW, that's going to correspond with this side right here of my other triangle? YX, okay? Just like this side right here, YZ corresponds with ZY, and XZ corresponds with Y or WZ, okay? So he messed up by putting these two sides as corresponding. So you want to put your corresponding sides equal to each other. So the way he could have fixed this is you don't put it equal to that, right? He should have put it equal to 4x plus 6. And then solved for x from there, all right? So that was his error. He didn't sit there and set up his corresponding sides correctly. All right, so I don't want to go too over time on this video. If you have questions on numbers 25 through 30, if you're following along in the book, put them in the comments. I will show you step by step how to solve them or answer any other questions you have. If you have other homework questions on geometry, put them in any of my geometry comment videos, and I will try to get back to them as fast as I can. So thank you guys. Please subscribe, leave messages, comments. I always try to give feedback as soon as possible. Thank you guys.